Okay, yeah. So from today we'll be starting linear regression. Yeah. So first we need to understand what is a regression. Okay. So in statics we have a term or a technique, a regression, in which we have some variables. Okay, we have some variables which are dependent on some independent variable. Okay. So if we take example of it, then we can say that we have a house. Let's suppose we have a house and we want to sell it. Okay. We have a house. We have like this giant house and we want to sell it. Okay, now we can say that a house can like as many as bedrooms or any rooms it can have. Okay, it can have 16 or 10 or rooms bedrooms. Okay, now the price we're gonna get, it depends on the bedrooms or the rooms it has. Okay, it depends on the bedrooms or the rooms it has. Okay, if a house has 5 rooms, then it have a lower price than the previous house. Okay, so yeah, the output will be higher for this house than this. Okay, the output of this house which have 5 rooms, which be lesser than the previous one which has 16 room. Okay, so the variable we're gonna get x is dependent on the bedroom. Okay, so the output depends outputs depend on the number of bedroom. So in the regression problem we have the same thing, in which we have been given a problem in which we have some kind of dependent thing which is dependent on some independent variable. Let's suppose we have a car. Okay, we own a car company like approaches us and tell us to get the sales of the yearly sale. What does we have? Okay, so, and it gives us the data, and it tells us the higher the horsepower, the more the car gets sold. Okay, the higher the higher the horsepower, HP. Yeah. Okay, the more the car is get sold, the more the car gets sold, which means the sales. Okay, so and we have added something linear in it. So what does linear mean? A straight. Okay, what does linear mean? Straight. Straight, yeah, this is what linear we know. And the regression, okay, we can say that linear regression is a kind of algorithm. Okay, we can say that linear regression is a kind of algorithm to solve that particular problem. If you don't know what an algorithm is, let me explain to you what an algorithm is. Okay, so according to me, like there are a lot of specific, I don't have a specific definition to it, but what an algorithm is, like it is a set of rules to solve a given problem to solve a given problem. Okay, example for example, let's suppose you have to prepare tea. Okay, let's suppose you have to prepare tea and you haven't given the instructions that this is the way you have to do it. Okay, so let's suppose you have seen your mother in the kitchen, that how she prepare a tea. So what you see, that she took the bowl, okay, or the pot, and she pour water into it, and she like put on the flame. Okay, and this is like okay, so not at good, but yeah, this is how that gas looks like. Yeah, so what she do, like she put the uh, pot, she pour water into it, she like put on the flame. Okay, this is the flame, she put on the flame and she turns on the gas. Now what you see, she adds the tea or the ginger, like as per your want. She adds the ginger or the sugar, the milk. So this is the way you prepare a tea. Okay, this is the way that I prepare tea. Like, don't ask me that I can prepare tea, but if I want, if there is a like critical condition, but yeah, this is how you prepare a tea, and this is something called algorithm. So this is something called algorithm. We have a set of rules how to do this, and you do like this as it has been said. Okay, we have all. I'm guessing that you have seen your mother. Yeah. So now we have no, we know that what an algorithm is. Algorithm nothing but a set of rules to solve a given problem, and a regression is a like technique in statics. Regression is a technique in statics in which variables are dependent variable or dependent on some independent variables. Yes, it is a technique, nothing but a technique. Now we have got what regression is. Now we're gonna see what is linear regression. Okay, linear regression. What is a linear regression? Linear regression is, we can say that it is a is a method in statics. In the method in the machine learning, static in the term of statics, it is a method to uh, get the relationship between the variables, the dependent variables. Okay, we can say that it is a method. Yeah, it is a statistical method that allows us to summarize and study relationship between two quantitative continuous variable features. Okay, we have, okay, if I write it, then linear regression is statistical method that allows allows us to summarize data and study study relationship between two quantitative quantitative. I have like a notes in which the definition has been written, so I'm writing from that, and this is from the Anton, like, yeah. So variables slash features. Okay, the feature is nothing but the input we have given to the model. Yeah. Okay. So we know now. The question rises is how to use linear regression. Like, and the second question is why we use linear regression. This is simple. Like, if you have a problem which dependent, which is forms a linear thing. Like, let's suppose if you have something five and it goes in a linear way. You have five, you get 10. You have 10, you get 20. Okay, so it's like double thing. So it gets linear in the increasing way. Okay, this is in the way of increasing. So yeah, this is why you use linear regression. If you have like for problem of like this, then you know this is of quadratic equation. You're not gonna use the linear equation in the schools, as you know. Like, if you have to use quadratic equation and you put the formula of linear equation, then it is not the right way to solve that question and get the answer. You'll get the, obviously you will get the answer, but you will be getting the wrong answer and you will be like started and beaten by your teacher. So now we have cleared this. What is linear regression? Why linear regression? Now how linear regression? This is a question. How will we use linear regression? And I'm telling you, it is a very vast topic. So we'll be like doing in some parts. Now let's suppose we have like told. I have told you in previous one that what in the representation what all those things matter. But now we'll be explaining in a best way so you can get it and like I can get it also because I'm learning in the phase. Yeah. So let's suppose you have given a data randomly. Like, let's suppose data I have like in front of me. Like, it is the previous one's data. It is like this. Okay, 140. This is the x. Okay, this is your x. This is your x, and this is your y. 140, 16, 225, 13, and like right at 150, 20, and 200. It's 18. Okay, so this is the form. This is the data we have, and this is in the form of linear. Like, if you can see, the higher the amount, the higher the y. Okay, the higher the x, the higher the y. It's like that. Now you have to build that model in a way that it predicts the value in the future also. Okay, you have to predict the value because you have a previous data. Okay, you have to like predict. Let's suppose we don't have any kind of number. Let's suppose we have 230. How will you get the y? Okay, you have x as a 230. How will you get the y? You don't have any answer, so you have to prepare the model in a way that it can predict the value from the new data, unseen data, like which will be given, and it can be in like many data set. Okay, like around 1 million, 10 million, or there are a lot of set of data. Okay, so yeah, so you have to build a model which is uh, give approx to y. Okay, you have to build a model. You have to give that kind of like numerical values which predict to y. Okay, in which we build a model. We build a function, not a model but a function, which is called hypothesis function. Okay, what we call it is a hypothesis function. By convention, like from some historical reasons, we call it hypothesis. There's nothing anything special in it. We call it hypothesis function from the historical reason, nothing else. Now what we do in it, okay, what we do in it is that we have some sort of coefficient like beta 1. Okay, so I have to like theta, but let's suppose beta and theta is, it's kind of a variable. You can take anything. So I'll take the theta. Okay, the theta 0 plus theta 1 into x. So it can be like enormous of term, many term based on the feature we have. So the feature we have only is x, the x, and that's why we have only two terms. So this is the coefficient. As we know, the equation of linear equation is like uh, y equal to ax plus b, okay, plus c. This is kind of like equation or something kind of. So y equal to ax plus b, yeah, ax plus b. Now we plot the data on the graph. Okay, we plot the data in the graph. So let's suppose this is the data we have. This is the kind of data we have, like around 6 to 5. I have put this. Okay, so now, and you draw a straight line by your hand. Okay, so let's suppose you have drawn this line. Now what your model has predicted, so let me change the color. So for this, for this data point, we have this much, okay, this much of space. So if you see, the model has predicted is this. Okay, this is the point for which this data point has been predicted. So this is what we call is predicted value. Predicted value, this is something called ground truth, which is the actual value. It is the actual value, this is the ground truth. And this is the error. What do we call it? This is the error which we got. Okay, this is the error which we got. The distance between this is the error we got. So we have predicted the model this. So how did we get it? How did we get to the line? Okay, so we have a function which was called hypothesis h of x equals to theta 0 plus theta 1 into xi for the like uh, for the x numbers. Okay, we have like x, we have a feature called x, but it is like n times. Okay, we have n times, so we have to like do it for each and every value. So we get a line for each, you're getting like each data set. Okay, for each number of data set. Now how will you write in a like uh, good form? So how will you write it? That which is approx to the h of hypothesis is approx to y. Yeah, how will you write this? H of x. Okay, this is the input. It will be summation from 1 to n, and this will be of your theta 0 plus theta 1 xi. This is something. Okay, this is something which we know, which will have this kind of function. Yeah, we know this function. Now we got the line, but we have to optimize this line in a way that it give minimum error. Okay, are you getting it? If you get a high error, like if we're getting higher, then our model is bad. But we have to we have to optimize this line in a way that it gives the minimum error. In the position it gives the minimum error. So how will you do it? So how will you do it? That we will tweak these parameters. Okay, as I have mentioned this earlier, that we call it as parameters or something called weight parameters or weights. So this is something I have mentioned earlier, but you have to optimize this line. And how will you optimize it? By tweaking these parameters, by tweaking this parameters, the theta 1 and theta 0. Okay, theta naught or theta 0. How will you optimize it? And how will we optimize it? By using the hit and trial method. By using the hit and trial method. And how will we optimize this? By getting checking the number, that how error rate our is. Okay, how good our model is, and for which value our y is giving the minimum error. Okay, for which value of thetas we are getting less error. Okay, so we'll need to check this also. Okay, huh, yeah, cool. So let's suppose the value which has been predicted is y hat. Okay, the value we have predicted is uh, the value we have predicted, let's suppose it is y and y hat. Okay, the value which has been predicted is y hat. Okay, and the real value was y. So we have to check that how far our point is from the real target variable. Okay, so what we have to do is here, is we have two things. We can square it, or we can take an absolute. What an absolute? Like it is the modulus, in which if we put any number which is negative or positive, we'll always get the positive side. Okay, because we don't want our model to get decreased. Okay, are you getting it? We don't want our model to get decreased. So that's why we'll use it. This, yeah, got it. Now, what we do, we'll check this number. Okay, we will check this number for every term. Okay, so y hat I minus y hat I minus y. So we'll getting the number for every and each value that we have predicted. So for so in the in the simpleton, how will we write it? That's we'll take mean of it. Okay, we'll take mean of it. How will we do it? Is like the number of errors. So let's suppose the error e1 plus e2 plus e3 plus, okay, so plus this is en. Okay, from the en and by m. Okay, because we have the m, or let's suppose n. Okay, n or m. So we take only n for n. Okay, so now how we do it? We have number n summation I till n. Now how will you do it? We will do it by this I minus, yes, this, and we'll square it, and we'll get our error our error rate or the cost function. Okay, or cost function. Okay, we'll use our cost function. Okay, the cost function will tell us that how far our model is from, how far our predicted value from the real target variable. Okay, this will tell us how far our predicted value is from the real value. Okay, this will tell, and we'll also get for which theta we are getting the minimum cost function. For which theta which theta we'll get the minimum will get the minimum cost function. Okay, the value of cost function will get the minimum. That's how we'll find the best theta for us. And how will you optimize it, and how will we get it? So we have an algorithm. What the algorithm here is, the algorithm is gradient descent. Okay, we have algorithm which is called gradient descent. Yes, gradient descent. Okay, so this is the algorithm gradient descent. This is the algorithm to optimize the line to get the cost function which we have the minimum. Okay, because we really don't know the program or the computer not like gonna tell us that this is the lowest point which you can use. So this is not the way, because if it could do, then why would need us for us? Okay, so like this, yeah. So this is a gradient descent, and I'm giving an overview. Just to gradient descent look like this. Like we have graph this and this, and we have the line like this. Okay, we have a line like this, not always like this, but we have a sort of like this, in which you can see the minimum. Okay, so the minimum is this. So we have to find this thing. We have to find this point, because if we get this point, then this is the highest, and we have to tweak our data, tweak our the parameters in the gradient descent, so we can get the minimum. Okay, this is the minimum. Okay, so this is the minimum distance from the real value. Yeah, so this is the gradient descent. So yeah, this was the thing, that how will you get. So I have told you that what is linear regression, how we'll use it, and we're not gonna in the large way, but yeah, so this was the thing. Now I'm gonna summarize it, but I really don't think we need to summarize it, because it is a very vast topic. So you can go back to get what the summary is. So yeah, I'll be seeing you in the next one. Bye bye. Goodbye. Bye.